let n factorial equivalent to 1 into 2 into 3. Those students who want to know, this is the previous year CAT previous year question. PYQ means previous year CAT question. Read the question. N factorial is 1 into 2 into 3 and so on up to n. He is giving you the definition of factorial. For integer n greater than or equivalent to 1, so there is a variable that is defined as 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on up to 10 into 10 factorial. 10 into 10 factorial. This is the expression. What is the remainder when p plus 2? Remainder when p plus 2 is divided by 11 factorial. P plus 2 is divided by 11 factorial. There is a expression that is attached to a variable 1 factorial, 2 into 2 factorial, 3 into 3 factorial and so on up to 10 into 10 factorial. What is the remainder when p plus 2 is divided by 11 factorial? First we will solve the traditional method. Traditional method, then we will discuss the Anil Nair's approach. Traditional method. How teachers, inexperienced teacher and students who probably do not know the optimized way, what they will do is 1 factorial. If you observe carefully, 1 factorial is 1. 1 into 1 factorial, it is 1. 1 into 1 factorial, 2 into 2 factorial, 3 into 3 factorial and so on up to 10 into 10 factorial. Observe the first term, 1 into 1 factorial. Second term, 2 into 2 factorial. Third term, 3 into 3 factorial. 10th term, 10 into 10 factorial. So nth term is given by n into n factorial. There are terms are getting added. Terms are getting added. So summation. N value is starting with 1 and ending at 10. Ending at 10. I hope it is clear. First term it is 1 into 1 factorial. Second term 2 into 2 factorial. 10th term 10 into 10 factorial. So it is n into n factorial. N is starting from 1 to 10. I hope it is clear. So this n can be written as n equivalent to 1 to 10. N can be written as n plus 1 minus 1 into n factorial. Plus 1 minus 1, it can get cancelled. Now if you observe, this is equivalent to summation n equivalent to 1 to 10. N plus 1 into n factorial, which is n plus 1 factorial minus n factorial. Minus n factorial. Now if you observe, this entire expression n into n factorial became n plus 1 factorial minus n factorial. N is 1. 1 plus 1 2 factorial minus 1 factorial. N is 2. 2 plus 1 3 factorial minus 2 factorial. N is 3. 4 factorial minus 3 factorial. N is 10. 11 factorial minus 10 factorial. Minus 2 factorial plus 2 factorial. Minus 3 factorial plus 3 factorial. Minus will have plus. So it is 11 factorial minus 1. So this will become 11 factorial minus 1 plus 2. 11 factorial plus 1 divided by 11 factorial. 11 factorial by 11 factorial. Remainder 0. 0 plus 1, 1. Answer for this question, it is 1. I am sure you might have seen this approach in almost all textbooks. 1 factorial, 2 into 2 factorial, 3 into 3 factorial and so on up to 10 into 10 factorial. Learning from this question, n into n factorial is becoming n plus 1 factorial minus n factorial. Minus n factorial. Traditional method, time waster method. Time waster method. I hope it is clear. Time waster method. This method will take a lot of time to solve. If you are listening to my class, you are listening to the class to learn new concepts and to find out better ways of solving problems and getting clarified all your doubts. This method, ideally in the examination, you should not use this method. I told this method to tell you that whenever you get patterns like n into n factorial, it is n plus 1 factorial minus n factorial. P is 11 factorial minus 1. 11 factorial minus 1 plus 2. Minus 1 plus 2 is plus 1. 11 factorial plus 1 divided by 11 factorial. 11 factorial out. Answer is 1. This is the traditional method. Now, Anil Nair's way of solving the question. Anil Nair's way. But before solving the solution, I am not interested in solving the solution. I am interested in telling you the patterns where you can use this concept to solve a problem. Question is, P is 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial and so on up to 10 into 10 factorial. The question is, remainder P plus 2 divided by 11 factorial. P plus 2 divided by 11 factorial. Yesterday we discussed one beautiful concept. I will repeat it. If the question contains numerical values, RHS contains numerical value. It is a collection of numerical values. If the question contains numerical values and the answer contains numerical values, answer contains numerical values. Go back and see this question. Question contains numerical values. Question contains numerical values. Answer contains numerical values. Question contains numerical values. Answer contains numerical values. Yesterday we discussed, we can approximate. We can approximate. Approximation, in other words, can also be told as we can optimize it. We can optimize it. Optimization. Or we can also do pattern identification. We will see what is happening because of by taking the smaller values and the same smaller values. Is it giving you the same answer or not? Write down this key point in your notebook. Wherever question contains numerical values, answer contains numerical values. One of the ways to solve a problem, it is not the only way, one of the ways to solve a problem is approximation method. What is approximation method? Now see here. Now see, listen carefully. 1 factorial plus 2 into 2 factorial. Now what I observed, the first thing I asked myself this question. Oh, it is ending with 10 factorial. Denominator is 11 factorial. If it is ending with 10 factorial, denominator is 11 factorial. Let me optimize it. 1 factorial plus 2 into 2 factorial. Oh, if it is ending at 10 factorial, denominator is 11 factorial. If it is ending at 2 factorial, denominator will be 3 factorial. I hope you are understanding the pattern, because the equation has been transformed to n into n factorial. If n is 2, the behavior will be the same. N is 10, the behavior will be the same. Smaller values, take it. So this will be 1 factorial 1, 2 2s are 4, plus 2 divided by 3 factorial 6. 7 divided by 6. 7 divided by 6. 6 1s are 6. Remainder it is 1. 6 1s are 6. Remainder it is 1. Oh, I did for 2 factorial. I got the remainder 3 factorial. Answer is 1. Let me check it out for one more number. Smaller values which you can do it. In competitive examination success, if you identify the different varieties of questions that are coming and practice that models thoroughly under the guidance of a teacher, I think you should be able to clear the examination in the first attempt. Now see here. P, 1 factorial it is 1. 2 into 2 it is 4. 3 factorial it is 6. Don't do 3 into 3, it is 3 factorial. 6 into 3, 18 divided by 24. Divided by 24. These 1 factorial plus 2. Plus 2. Don't miss it. Don't do only P. It is P plus 2. 18 plus 2 for 22, 25. 25 divided by 24. It is 1. Therefore, the answer is 1. That means from now onwards, if there are higher powers given, question contains numerical values, answer contains numerical values, approximate it to. Generally for n equivalent to 1, most likely you will Get two options eliminated, n equivalent to 2, n equivalent to 3. This is the best way of solving approximation or an optimization method. Approximation or an optimization method. Pattern identification, it is clear. Each and every term is of the form n into n factorial. Each and every term is of the form n into n factorial. Idea, it is clear. Now if an IITN or an NIT student or a smart max student is solving, sir, the question is 11 factorial plus 1 divided by 11 factorial. What is 11 factorial is not present. Some other number, it is present. If some other number, it is present. Utkarsh, one of my student, right, asked me this question. Question is, listen carefully, sir. But before that one, question is 40 factorial is 40 factorial plus 1 prime or composite is 40 factorial plus 1 prime or composite. Very, very good questions. Is, in my class you will get all very, very good questions, sir. 100 factorial plus 1 prime or composite. 100 factorial plus 1 prime or composite. 17 factorial plus 1 is divisible by 17 factorial plus 1 is divisible by 3, 11, 13, none of this. 3, 11, 13 and none of this is 40 factorial. Similarly, question is 10 factorial plus 1 prime or composite. Prime or composite. Write down this question. You know about my class. There will not be a PPT and the solution. Take a question, understand the concept, create as many questions as possible so that a student will understand the concept in detail. Is 40 factorial plus 1 prime or composite. 100 factorial plus 1 prime or composite. Now, if you see here, first concept, to identify whether factorial numbers plus or minus k or is it giving you prime or composite. There is a famous mathematician who has done a lot of research on prime numbers, Wilson's theorem. He has proposed a lot of concepts. Let me write down all the theorems and their corollaries. P minus 1 factorial by p, it is p minus 1 when p is a prime number. When p minus 1 factorial divided by p, remainder will be p minus 1. Remainder when p minus 2 factorial divided by p, it is always 1 when p is a prime number. Extremely important concept. Remainder when p minus 3 factorial, p minus 3 factorial divided by p, it is p minus 1 by 2. What if it is beyond 3? In an enrolled batch, we discussed in detail. P minus 1 factorial by 1 p, it is p minus 1 p when p is prime. Proof is also very, very easy. Remainder when p minus 2 factorial divided by p, it is 1. Remainder when p minus 3 factorial divided by p, it is p minus 1 by 2. Please put a star mark, write down in your notebook. This will help us to solve some complex problems very, very easily. Now see here, is 40 factorial plus 1 prime or composite. 40 factorial is divisible by 2, divisible by 3, divisible by 40 factorial is the product of all natural numbers from 1 to 40. So these are divisible, 1 is not divisible. So you have to find out a prime number greater than 40. Now, first question, if I check it out, 40 factorial plus 1 divided by 41. So 40 factorial is the product of all natural numbers from 1 to 40. This is divided by 2, 3, 4 and so on up to 40 plus 1. That means numerator is not divisible by any natural number from 1 to 40. Am I right? So p minus 1 factorial divided by p, it is p minus 1. P is a prime number. 41 is a prime number. 41 minus 1, 40. 40 plus 1, 41. So it is 0. That means this number is divisible by 41. If it is divisible by 41, how can it be a prime number? Idea, it is clear. Denominator, we took 11 factorial. Denominator, if it is a prime number or if it is a composite number, then the entire question significance will change. How to solve the question? If you see here, denominator, it is just 11 factorial. Denominator can be a natural number. Natural number can be a prime number or a composite number. Natural number can be a prime number or a composite number. All that models we have to discuss in detail. Now, answer for the first one, it is divisible by 41, it is composite. Second question, 100 factorial plus 1. 100 factorial. 100 factorial is the product of all natural numbers from 1 to 100. So, this number, numerator is not divisible by any natural number from 1 to 100. P minus 1 factorial by P. It is divisible by P minus 1. 100 plus 1. 101. 101 is divisible. Second one, it is divisible by 101. So answer is composite. Utkarsh is my CAT enrolled students. He has kept this message in the Telegram CAT enrolled batch. Next one. 17 factorial plus 1. 17 factorial. Third question. All are logical questions, sir. 17 factorial plus 1. It is 17 into 16 and so on up to 3 into 2 into 1 plus 1. That means this is divisible by 3 plus 1. Answer is not divisible by 3. This is divisible by 11 plus 1. Answer is not divisible by 11. This is divisible by 13 plus 1. Answer is not divisible by 13. Answer for this question will be none of this. Answer for this question will be none of this. Please write down, sir. P factorial plus 1 is not divisible by P factorial plus 1 is not divisible by any natural number, is not divisible by any natural number from 1 to P. It is very obvious. Why? Because P factorial only is the product of all the natural numbers from 1 to P. Idea, it is clear. Next, fourth question. Fourth, easily you can solve. 10 factorial plus 1. So, 10 factorial plus 1. P minus 1 factorial plus 1 divided by 11. These 10 plus 1. This number is divisible by 11. Answer, it is composite. Answer, it is composite. Put a star mark on this concept. In this concept, we are going to discuss Wilson's theorem. We are going to discuss Wilson's theorem. Primitive part, I will put it as a free add-on to the non-enrolled students. To the enrolled students, we discuss some very, very good questions like 35 factorial whole square divided by 71. 8 factorial whole square divided by 17. He might give you this kind of question. This is an easy question. Reminder 1. 23 factorial is divided by 17. 23 factorial. It contains 7 as one of the numerical values. Answer is 0. Answer is 0. I hope the idea, it is clear. Answer is 0. Denominator we took in the first question, it is factorial. But what if instead of factorial, if it is a prime number? Wilson's theorem. The third one, it is very important. Otherwise, it will take a lot of steps. P minus 3 factorial divided by P. Please make a note. Whenever factorial numbers are there in the numerator, when it is divided by prime number, you have to use Wilson's theorem. Wilson's theorem is used to find the reminders when the numerator is a factorial format and the denominator, it is a prime number. Idea, it is clear? Idea clear? Right. I hope the idea, it is clear. Sir, what if the denominator, it is a composite number? Denominator, these slide is extremely important, sir. Denominator can be a prime number or it can be a composite number. Denominator can be a prime number or it can be a composite number. If it is a prime number and the numerator is in factorial, use Wilson's theorem. Use Wilson's theorem. Use Wilson's theorem when the numerator is in a factorial format. If the numerator is a power, If the numerator is a power, then you can use negative remainder. If a negative remainder is not giving you the answer, then you have to use Fermat's theorem. Then you have to use Fermat's theorem. This is the flowchart to solve the problems. Not a single doubt, you will get it in my class. Next one, if it is a composite number, first use a negative remainder. First use a negative remainder. If it is taking more time, use Euler's theorem. If Euler's theorem is taking more time, use Chinese remainder theorem. Use Chinese remainder theorem. What is the Chinese remainder theorem? Write down that composite number. Write the composite number as a product of two coprimes. As a product of two coprimes. As a product of two coprimes. 12 can be written as 3 into 4. 35 can be written as 5 into 7. There is one drawback with the Chinese remainder theorem. Square of a prime number. Square of a prime number. Square of a prime number cannot be written as a product of coprimes. Product of coprimes. Product of coprimes. 3 square, it is 9. It cannot be written as a product of coprimes. 3 into 3, HCF of 3 comma 3, it is 3. Coprime means their HCF should be 1. Coprime means their HCF should be 1. HCF of A comma B should be 1. HCF of A comma B 1. A and B are coprime. A and B are coprime. 81. 81, it is 9 square. 9 itself is derived from this number. 1 into 81. 3 into 27. 9 into 9. Where you are able to write composite number as a product of coprimes. Right from March 2nd week, we are starting with an mock cat paper designed by Anil Nair discussion. In one of the papers, I create a question. Which of the following numbers cannot be written as a product of coprimes? Which of the following cannot be written? Primitive level, it is a square of a prime number. 81 can be written as 9 square. It can be written as 3 power 4. Or even power of a prime number. In simple language, even power of a prime number. Even power of a prime number. This is a basic version and it is a derived version. Suppose even power 2 power 4, 16. How can you write 16 as a product of coprimes? 1 into 16, 2 into 8, 4 into 4. HCF of two numbers is never 1. Suppose if I take 5 power 4, 5 power 4 is 625. 1 into 625, 5 into 125, 25 into 125. Listen carefully to each and every key point of mine. Whatever I am telling to you in this class is a learning from 50 plus number system books. Whatever that you are listening, that one statement, some hours of sleepless nights I spent in understanding this concept thoroughly, with absolutely zero doubts, you will understand it. Not a single doubt. Sir, then how to solve this kind of problems? It is not there in your syllabus. For an MSc mathematical students who are appearing for MSc Maths examination, students are appearing for Indian Statistical Institute, India's finest mathematical institute. For them, I will teach Carmichael function that is not there in your syllabus. This is the flowchart to solve remainder problems. Whenever you find remainder problems, ask yourself this question. Is the denominator prime number? Use the negative remainder. If the numerator is not factorial, if it is giving you more time, use Fermat's theorem. Entire remainder sessions are absolutely free. Entire remainder chapter, almost 5 to 6 sessions, it is absolutely freely available in Anil Nair classes YouTube channel. You can go and you can watch it. entire reminders. Those students who are struggling in reminders, this is the flow chart to solve reminder based problems. Do not solve hundreds of questions. Solve the questions in a structured way. If the denominator is a composite, I will use this. If it is taking more time, I will use this. If it is taking more time, I will use this. This concept will not be applied when the number is a denominator is a product of coprimes. Crystal clear clarity.